So imagine you have an employee class with the properties like employee name, employee age, employee salary. Okay. So suppose you have the scenario like you want to sort a list of employee objects based on employee name. So can you explain how we can achieve that?
Yeah, the to sort the list of employee objects based on the employee name property, we can use a comparator. So yeah, so comparator we can use. So for that, what we can do, like we can have the employee class, and we can add the constructors of these properties over there, this name, age and salary, and getters and setters. And then we can add these objects to the list of employee, and after that we can perform collections dot sort. So in collection dot sort we can pass this employees list comparator, we can pass in that, and we can override this compare method, and we can pass the employee e1 and e2, and there we can use the further compare to, and further the result we can print, so it will be into the sorting order.
Okay. So what is comparable in Java?
A comparable is an interface in Java that is used to define the natural ordering of objects. So when a class implements the comparable interface, it provides a single method called compare to, so which is used to compare the current object with another object of the same type. So this comparison determines the order of object in a sorted collection. So this is the part of java.lang package. Yeah, so this is what the comparable is.
So can't we use comparable in the previous answer which you gave?
Yeah, actually, we can use the comparable to sort the list of employee objects based on employee name. So, like it is like when we have the scenario like when uh, we have to sort based on more than one property. So in that case, we go for comparator. But suppose if we have to sort on only one, then we can go for comparable. So I took the comparator because suppose in future if we have the scenario like we have to also sort in some situations with other properties. So yeah, that is why I choose comparator. But yeah, if we know that we have to sort based on only one property always, then we can use a comparable. Yeah.
Okay, what is the difference between callable and runnable in Java?
Yeah, in Java, both callable and runnable interfaces are used to represent tasks that can be executed by a thread or an executor service. However, there are key differences between them, so primarily related to the return type and exception handling. So, whenever we use runnable, so it provides a method called run, and its return type is void. Coming to callable, it has call with generic return type. So in runnable we cannot throw the exceptions, and in callable the exceptions can be thrown. And then so basically runnable can be used either with the thread or executor service, while callable can only be used with the executor service, and it returns a future. So basically runnable is suitable for task without result or exception, and callable is suitable for task with result or exceptions. Runnable, when we don't need to return a result or throw a checked exception from our task, then we can use runnable. Callable we can use when we need to return a result from our task or throw a checked exception.
Okay, so how are you managing exceptions in your project?
Yeah, the exceptions can be either checked exception or unchecked exception. So, checked exception and used for recoverable conditions and are handled using try catch blocks. So these are typically application specific issues like any validation errors, file not found, or database connection failure. So in these scenarios, an unchecked exception happens at runtime. So it is used for programming errors that are not expected to be caught during normal operations, such as null pointer exception or array index out of bound exception. Yeah, so these are the exceptions. Then again, we have errors. So some unprecedented situation happens, like um, something like a stack overflow or out of memory error. Then we also have centralized exception handling. So like we use a centralized exception handling mechanism to handle exceptions consistently across the applications. In the web application, this is often done using a global exception handler. So in Spring based applications, for example, we use at the rate of controller advice to create a global exception handler. So on top of class we can give add controller advice, and then in the method level, so we can give at the head of exception handler, and we can further handle the exception over there. So yeah, and we can also do custom exception handling. So we define a custom exception class to represent a specific error condition in our application. So like this helps in providing like kind of more meaningful error messages. So in that, for example, we can extend the runtime exception. In the method we can pass, let's say, string message, and that super message we can give, so it will ultimately show the custom exception in that. And further we log it. So we use log4j or self4j, slf4j to log these exceptions. So yeah, so this is how we are handling it in our application.
Can you explain what is deep cloning?
So there are two types of cloning: shallow cloning and deep cloning. The difference between them lies in how they handle the cloning of objects field, particularly if the fields are references to other objects. So shallow cloning creates a new object, but it does not create copies of the object that the original object references. Instead, it copies the references of those objects. Therefore, both the original and the cloned objects share references to the same objects. So shallow cloning copies the object's fields as they are, meaning it copies the references for any object referenced to by the fields. Then in deep cloning creates a new object basically, and also creates copies of the objects referenced by the original object's fields. So this means that the cloned object and the original object do not share references to the same object. It means if we change something in that, so both will be independent of it. It won't be updated to uh, the first object. So instead they each have their own copies. Okay, so deep cloning involves recursively copying all the fields of the objects, ensuring that all referenced objects are also cloned.
What are the Java 8 features you are aware of?
There are many features. Lambda expression is there, then stream API is there, functional interface is there, and then default and static methods are there, and optional class is there, datetime API is there, and method referencing is there. So yeah, these are the, I mean, features which I am aware of.
Okay, can you explain what is consumer?
Yeah, consumer is a functional interface in Java that is a part of the java.util.function package. So it has been introduced in Java 8. It represents an operation that takes a single input argument but returns no result. So the primary purpose of a consumer is to perform side effects via its accept method. So its common use case is while processing collections. So the for each method in the iterable interface uses consumer to perform an action for each element of the collection. So while chaining consumers also, we can chain multiple consumers using there is a term called and then. So this allows us to perform multiple operations in sequence. So basically it takes single input argument and returns no result.
Okay, so what are the different states of a thread in Java?
Yeah, so we have like new, runnable, blocked, waiting, uh, then terminated. So yeah, these are the various states we have.
Okay, can you explain all these in very brief?
Yeah, so new means the thread is created but not yet started. So we say it is in new state. Then runnable is the thread is ready to run and waiting for CPU time. Then blocked, so the thread is waiting to acquire a lock to enter a synchronized block or method. Then waiting means the thread is waiting indefinitely for another thread to perform a particular action. And then the thread has completed its action, then we say then it is in terminated state.
Okay, so how can you create thread in Java and what are the various ways?
So there are basically two main ways to create a thread in Java. One is by extending the thread class. So we can do like class, let's say my thread, and then extends thread, and then we have a method called run, public void run. So whenever we create the object of my thread class, and we say and that with that object we say dot start, then it calls the run method. So that is how we can, this is the first way. Second way is by implementing the runnable interface. So for example, we have a class my runnable and that implements runnable, and this also has a run method in it. But what we do in this case is that we say like create the new object of the thread, and in thread we again pass the object of my runnable class. Okay, so which has actually implemented the runnable, and then further we can use this thread dot start. So yeah, so these are the two ways.
Okay, so what is a deadlock and how we can avoid it?
Okay, so deadlock is a situation in which like two or more threads are blocked forever. And suppose we have thread 1 and thread 2, and thread 1 is suppose running and thread 2 is also running, and thread 1 is waiting for thread 2 to be released so that it can further proceed, and similarly thread 2 is also waiting for thread 1 to be released and so that it can also proceed. So it is like they are waiting for forever uh, to release the resources for each other. So this is what is the deadlock is. And this can be avoided by various ways. We can avoid like nested locks, so like acquiring multiple locks within each other. And we can also say like using a timeout for thread locks, and we can also avoid unnecessary locks. And also through the lock ordering also we can avoid it, so we can ensure that all threads acquire locks in the same order. So yeah, so these are the various ways we can avoid it.
So what is solid principles in Java?
Each letter in solid stands for different principle. So for example, S stands for single responsibility principle. So it states that a class should have only one reason to change, meaning that a class should have only one job or responsibility. So this principle promotes cohesion and reduced coupling, making classes easier to understand, test, and maintain. And then coming to O, so O means open closed principle. So software entities like classes, modules, and function, etc., should be open for extension but closed for modification. So this means that you should be able to extend the behavior of a module without modifying its source code. So this is typically achieved through the use of abstraction and polymorphism. Then L stands for risk of substitution principle. So objects of a superclass should be replaceable with objects of its subclass without affecting the correctness of the program. So like in other words, derived classes must be suitable, derived class must be substitutable for their base classes without altering the desired behavior of the program. So this principle ensures that inheritance is used correctly and consistently. Then I stands for interface segregation principle. So clients should not be forced to depend on interfaces they do not use. So instead of one large interface, it's better to have a smaller specific interfaces that are focused on particular behaviors. This reduces the risk of clients depending on methods they do not need, so which can lead to unnecessary coupling. Then D stands for dependency inversion principle. So high level modules classes should not depend on low level module classes. So both should depend on abstractions. Abstractions should not depend on details. So details should depend on abstractions. So this principle decouples classes and modules, making the code more flexible, reusable, and easier to test.
So what are the collections which you have used?
Yeah, I have used on, I have worked on various collections like in list, we have array list, linked list, hash set, linked hash set, then in maps, hash map, linked hash map, and again a little bit on queue as well. So yeah, so these are the things I have worked on.
Okay, so tell me one thing, that how do you decide that you have to use set or list?
So, uh, deciding whether to use set or a list, that completely depends on the specific requirements of the task. So, for example, if we have to preserve the insertion order, then we use list, like array list and linked list to maintain the insertion of order. And if we have to access by index, then also we use this list. And suppose if you have to maintain the uniqueness, then we go for set. And if we require duplicates, then we can use list, right? So also if the order of the elements does not matter, we use hash set. And if we want to maintain the insertion order, then we can use linked hash set. So basically we can use list while maintaining a list of tasks in order they were added, and accessing a list of items by their position, such as let's say fifth element, then we can use list. We can use set for sorting a collection of unique usernames, for example. and keeping track of unique configuration settings. So yeah, so this is the scenario how we can use these two.
So what is queue in collections?
In the Java collections framework, a queue is a collection designed to hold elements prior to processing. So basically, it follows the first in, first out principle, where elements are added to the end of the queue and removed from the front. So this makes queue useful for tasks where the order of the processing elements is important, such as scheduling and buffering. So some common implementations of queue are like linked list is there, and then priority queue, array D queue. So yeah, basically in the queue elements are added to the end of the queue and removed from the front. So that is the FIFO behavior. Yeah.
Okay, so what do you use to monitor um, everything in your Spring Boot application?
To monitor, so monitoring a Spring Boot application, we use actuator. So there is something called actuator in Spring Boot. So we can use health status. So and we can use metrics. We can use info. So using this, we can find out what are the errors are occurring, and uh, which applications are not performing, what resources it is consuming at the moment. Yeah, so basically we use actuator for the monitoring purpose.
So suppose any problem happens to your application, Spring Boot application. Basically, how do you check the logs and rectify it?
We follow so first of all we check in local logs. So we can check local logs, and also we have the centralized logs. So for the centralized logs, we have Splunk. So this Splunk basically gives one URL. So we can hit that URL, and we can get all the information what is the issue. And in case of local logs, if the logs are stored on the file system, so we access them directly via SSH or through a file explorer. So by default, Spring Boot logs to the console and can be redirected to a file using configuration in like whatever we are using, application.properties or application.yaml. So once we have the error description, then we analyze it. So we start searching with the keyword like error or exception. So now we check the possible reason why it is not performing. So again, we can have various reasons for it. So we might have the any application down. So we can have again some callback methods for that application, or sorry, for that server which is not responding. So again, there are various ways, and based on the whatever error we have got, so we analyze that and we rectify based on that, and we take the actions accordingly. So these fixes can be like, it may be code change, it may be configuration change, it may be on infrastructure change or issue. So based on analysis of these, we can further proceed with the further changes.
Okay, so do you know what is vertical scaling and horizontal scaling?
Yeah, vertical scaling, also known as like scaling up. So this involves like of more power or more CPU RAM storage to an existing server, uh, or upgrading to a more powerful server to handle increased load. So suppose we have like existing CPU with 16 GB RAM, and once with the increasing load, suppose we upgrade it to 32 GB RAM, so same server. So this scenario we say it is a vertical scaling. So whereas in case of horizontal scaling, so suppose we have one server of like again 62 16 GB of RAM. So we bring another server of 16 GB RAM. So this is what we say like is the horizontal scaling. So we uh, in case of vertical scaling, so we increase the resources, CPU, memory, storage of a single server, and it's easier to implement because it usually involves upgrading of existing hardware or virtual machine specifications. And the problem with this is whenever uh, if the server fails, then entire application can go down because everything is on that server itself. But this is not the case in with the horizontal scaling. So we since we have many servers, so if one instance is down, then the load can be shifted to the other instances. So with the cost wise also, this vertical scaling, it can be cost effective up to a certain limit only, but it can be very high end hardware, so it can be very expensive as well if it is a high end hardware. In microservices architecture, normally we use horizontal scaling. So we add so more application servers behind a load balancer to handle increased web traffic.
Okay, so how do you deploy your application in case of horizontal scaling?
Yeah, we deploy it using Tomcat only because we use Spring Boot and it has inbuilt server Tomcat. So yeah, so we are using Tomcat itself. However, we can use other servers also. Uh, so in case of Maven application, so in pom.xml, so what we can do is we can add exclusion tag, and there we can put uh, the artifact ID of the Tomcat, and so basically this will not include that, and whatever server we want, suppose jetty we want, then in the dependency we can add that, so that server will be added. So yeah, this is how we can do it.
Okay, so can you tell me when do you use application.properties and when you use application.yaml?
Yeah, so in Spring Boot, application properties and application.ml are configuration files used to set various properties for the application. So basically, both serve the same purpose, but suppose we want to keep it simple and we want to use a simple key value pair format, then it is application.properties which we go for. But uh, in YAML, basically it follows the hierarchical way, and it is basically more easier to understand and read the complex configuration. Suppose some configuration in which we have like x dot y dot z, and again suppose if we have another properties like x dot y dot a, x dot y dot b, like that. So we don't have to repeat it again and again all this. So we can just say x and then colon, and then tab we can give the y, and then colon we can uh, further tab we can give, and like a we can give, and we can define its value. So basically, it is kind of hierarchical way of defining uh, uh, the configurations, and mostly we prefer to use YAML only in case of complex configurations. So yeah,
Okay, so have you worked on microservices as well?
yeah, I have worked on it. We are having monolithic application, and currently like we are migrating that to microservices. So yeah, so we are in the process of doing that.
Okay, so can you tell me what is this API gateway?
Yeah, API gateway is a crucial component in a microservices architecture. So serving as a single entry point for client request to the various microservices. So it acts as an intermediary that handles all the interactions between the client and the backend services, providing a range of functionalities such as routing, composition, security, and more. So for request routing, we use it like routing the incoming client request to the appropriate microservices. So it understands the available services and required routing logic to direct the request correctly. And for load balancing, it distributes incoming traffic across the multiple instances of microservices to ensure no single instance is like overheaded, and to enhance the uh, and to enhance the reliability and performance. So for authentication and authorization also we use it. So it's kind of you can say as a gatekeeper by enforcing security policies, managing user authentication and authorization before forwarding request to the microservices. And uh, and it also provides centralized logging, monitoring, and analytics for all clients interactions with the microservices, facilitating better tracking and debugging of requests. It also implements caching mechanism to improve performance by storing and serving frequently accessed data without needing to query the backend services every time. So that mechanism also we can use here. So some of the API gateways are like Joule, which is provided by Netflix, and then we have AWS API gateway. So yeah, so these are the few popular API gateways.
So how does the microservices communicate with each other?
Yeah, so in our application, microservices communicate with each other using service discovery. So basically, service discovery is a critical aspect of communication in a microservices architecture, facilitating dynamic and scalable interactions between services. So without hardcore dependencies. So basically, as soon as the microservices start, so it registered itself with the service discovery mechanism. So and that registration basically includes it location, IP address, port, and health status and all. And like all the services registered to this. Suppose one microservice has to call another microservice, so it does not directly calls that another microservice. Instead, it goes to service discovery, and in the service discovery, whatever the URL it has, so that URL actually it hits and it gets the data from there. So yeah, so basically service discovery is the process by which services dynamically find and communicate with each other in a distributed system. So yeah.
Okay, so can you explain what is Hystrix?
Hystrix is basically a way to prevent cascading failures, and it provides fallback options. So, for example, suppose we have a microservice A and it calls B and B calls C. So, suppose uh, A and B is working fine, but C is failing. So, for some reason, C is down. So, in that case, so C will not return any result. So, this is a failure case, right? And this is what we say the cascading failure. And to prevent this, we use circuit breakers for that. So basically, Hystrix implements the circuit breaker pattern to stop cascading failure in distributed system. So when a certain threshold of failure is reached, so Hystrix opens the circuits, preventing further requests to be executed. So this helps to reduce latency and conserve resources. So then it provides a fallback mechanism. So instead of sending the error or not responding anything, so we basically write a fallback mechanism, and some default method is called in case of failure. So basically it does not fills the whole application, and some default return we can do.
Okay, can you tell me what is stored procedure?
Yeah, stored procedure is a pre-compiled collection of SQL statements stored in the database and can be called and executed by its name. So it can accept input parameters, perform operations, and return multiple result sets. So suppose any query is there and we want to run it over and over. We always frequently need it, and we can also uh, dynamically pass the parameters, input parameters to that, so that it can get the and it can fetch the corresponding data, so we don't have to write the same code again and again. So yeah.
Okay, so what is trigger? Do you know what is trigger?
Yeah, a trigger is a special type of a stored procedure, we can say, that automatically executes in response to certain events on a particular table or view. So triggers are used to enforce business rules, maintain referential integrity, perform logging, and automate complex database operations. So basically, triggers are fired in response to specific events such as insert, update, or delete, or select also in some databases. And it executes just before or after triggering event occurs. So maybe just before, for example, just before insert and before update and before delete and after insert, after update, and after delete. So suppose we have to do some logging or auditing of a table, like whenever any hit is coming to that table, any modification is happening. So suppose we want to monitor it, and we want to log it somewhere, so we can do that. So yeah, this is one of the use case when I have used in our project.
Okay, so can we have more than one primary key in a table?
um in Yeah, we can have, like in MySQL, we have the concept of composite primary key. So which means that primary key can consist of multiple columns. So basically this is like kind of combination of more than one column. We make it as primary, and each combination of value across these columns must be unique within the table.
Okay, so can you tell me what is the purpose of join and what is the purpose of union? So when we should use join, when we should use union?
Okay, yes, join and union are both operations used in SQL to combine data from multiple tables or queries, but they serve different purposes. So in case of join, so they are used to retrieve data from two or more related tables based on related columns between them, and union is used to combine the result of two or more select statements into a single result set. So this is the major difference. And so in join we have various types, like we have inner join, left join, right join, yeah, and full outer join. So these are the various types of joins we have. And in case of union, we have union and union all. And one more thing in case of union is like the select statement in the union must have the same number of columns, and columns must have compatible data types. So union removes duplicate rows unless union all is used.